Hello students, in this video I would like to discuss about construction of a predictive parsing table. So this is algorithm to construct a predictive parsing table. So the predictive parsing table is constructed based on the functions first and follow. So the input will be a grammar G, output will be a parsing table M. For each production A gives alpha of the grammar, I have to do some 3 steps. For every terminal A in first of alpha, add A produce alpha in M of A comma A, where capital A is a row and small a is a column. Second step, if epsilon is in first of alpha, then for each terminal B in follow of A, add A gives alpha to M A comma B. If epsilon is in first of alpha and dollar is in follow of A, add A gives alpha to M of A comma dollar as well. If after performing the above, there is no productions at all in M A comma A, then set M A comma A to error, which we normally represent by an empty entry in the table. So this is the procedure for constructing a predictive parsing table. So I will try to explain the construction of predictive parsing table with an example. So these are the major steps in construction of parsing table. Here I have a grammar. This grammar we have already discussed. From this grammar, we already found first and follow. This is a format of parsing table where row represent all the non-terminals and column represent all the terminal symbols including dollar. So here you look at these productions. Now need to consider these productions again because this is only to find first and follow. So first production is E gives T dash. That means I have to place this production somewhere in the parsing table. I have a production E gives T dash. My aim is to place this production in this parsing table. So since the left hand side is E, this production will be placed in the E row. That means this first row. So next question is where to place this E raised T dash. E raised T dash is placed in E row under first of T dash. First of right hand side. First of RHS, that is T dash. First of T dash means first of T, because in T dash the symbol T is the first. So first of T dash means first of T. So what is first of T? ID and opening bracket. So in each row under ID and under opening bracket I am going to place E gives T dash. Similarly, I have another production E dash gives plus T dash. So anyway, this production is going to be placed in this second row, that is E dash row. So where it will be placed? It will be placed in first of plus T dash. First of plus T dash is nothing but plus. So under plus I am going to place E dash derives plus T dash. Another production is also there. E dash gives epsilon, that we will consider later. So all the epsilon productions will be considered later. So I am moving to next production. T gives ft dash. So this production will be placed in this Tth row. Where it will be placed? First of ft dash. First of ft dash means first of f. First of f is ID and opening bracket. So T gives ft dash is placed under ID and opening bracket. Similarly, I will move to next production. T dash gives star ft dash. Again, it will be placed on T dash row. Where? Under star, because first of star ft dash is star. Next I am moving to next production. F gives ID. So first of ID means ID. We already studied first of a terminal symbol is that terminal symbol itself. So F gives ID will be placed in Fth row under ID. Similarly, F gives E within bracket will be placed in first of E within opening bracket and closing bracket. So that first will be opening bracket. So F gives E within bracket is placed under opening bracket. So it's a very simple step. So next we have to look at the epsilon productions. Here I have a production E dash gives epsilon. If there is a production E dash gives epsilon, then it is placed in E dash row under follow of E dash. That is under dollar and closing bracket. So in E dash row under dollar I placed E dash gives epsilon, and also under closing bracket I have placed E dash gives epsilon. So if there is an epsilon production E dash gives epsilon, it will be placed in E dash row under follow of E dash. So under row E dash we are going to place it in dollar and opening bracket, since follow of E dash is dollar and opening bracket. Similarly here also I have an epsilon production T dash gives epsilon, so that T dash gives epsilon will be placed in follow of T dash, that is it will be placed under plus, under dollar and closing bracket. So this is how the parsing table is constructed. So before moving to the working of parser, I just want to give a brief summary about what we have studied earlier. So we all started with this grammar. This is a context-free grammar. But if you remember the previous videos, it is an ambiguous grammar which doesn't consider associative and precedence. So this grammar is converted to another format where associative and precedence is considered. While associative is done, we know it causes left recursion. We already discussed we have to avoid left recursion. So after avoiding left recursion, I got a grammar like this. From that grammar, we estimated first and follow, and based on that first and follow, we created a parsing table. So the aim of the parser is to convert a given input string into a parse tree. So I will try to explain how a parser will convert a given input string to parse tree with the help of an example. This is the model of table driven predictive parser. There will be a stack, and bottom of the stack will always contain dollar. We all know there is a pointer called top which points to the top of the stack. If top of the stack points to dollar, the meaning is stack is empty. Also we have an input buffer where the input string is stored. To denote end of the string, we used a special symbol called dollar. And we have a parsing program, we have a parsing table, and we will get parse tree as the output. So here what we are going to study is working of this predictive parsing program. So this is algorithm for predictive parsing. Initially the parser is in configuration with ws dash in the input buffer, and the start symbol s of g on top of the stack above dollar. The algorithm uses the predictive parsing table M to produce a predictive parse for the input. So this is the predictive parsing algorithm. When we saw the example, it will be more clear. So in the initial setup, in the input buffer, we will store the input string followed by a dollar. One more thing, in stack, above the dollar, we will place the start symbol. So that's the initial configuration. So I will try to explain with the help of an example. So here I have a parse table. Here I have the input buffer. So I am going to convert this id plus id to a parse tree. So the end of the string is denoted by dollar. I have a stack. At the bottom there is dollar. After initial setup, that start symbol will be pushed to stack. Here in this grammar, start symbol is E, so E is pushed to stack. So initially ws in the input buffer, start symbol s of g on top of the stack above dollar. Above dollar I placed E. Let A be the first symbol of W. Here W means id plus id, and I have a pointer A which points to first symbol of W. Here id is the first symbol of W. Let X be the top stack symbol. So X is a pointer which points to top of the stack. So you just look at this while condition, while X not equal to dollar. Anyway, X is E, that is not equal to dollar. So this while loop will be executed. If X equal to A, X is E, A is ID, E equal to ID is false. So this statement will not be executed. else if X is a terminal. X is not a terminal because it is E, that is a capital letter. Else if M x comma A is an error entry. What is M x comma A? Here X is E, A is ID. So in each row you have to look at column ID. So you have to check whether this entry is an error. Already discussed, in a parsing table, this empty cells represent error entries. Empty table entries represent error. So this is not an error. Else if M of x comma A equal to X gives y1, y2 up to yk. So here in M of x comma A, that is M of E comma ID, I have a production. That production is E gives TE dash. So this condition is satisfied. So what I have to do? Output the production X gives y1, y2, yk. So I have to print this production as output. E gives TE dash as output. So I have print that production as output. What is the next step? Pop the stack. So this E will be removed from the stack. So E is removed from the stack. Push yk minus 1 up to y1 onto stack with y1 on top. So here I already considered the production E gives TE dash. I have to insert this RHS in the reverse order. That's the meaning. Here production is y1, y2 up to yk. But when I push to stack, first yk is pushed, then yk minus 1 is pushed, and then y1 is pushed. So here I got E gives TE dash. So first E dash will be pushed to stack. On top of that, T will be pushed. So this step is very important. You have to push the right hand side of the production in reverse order. E dash will be pushed first, then T will be pushed. So E dash and T are there in stack. Now X, the top of the stack, points to T. Again, this while condition will be checked. X is not equal to dollar. Then we will check whether X equal to A. X is T, A is ID. So this condition is false. Then we check whether X is a terminal. X is not a terminal. Then we will check whether X comma A is an error entry. Here X comma A means T comma ID. So Tth row, first column, that is not an error entry because it is not empty. So this condition is true. So you have to output the production. Here T gives ft dash will be printed as output. So T gives ft dash is printed as output. Pop the stack. So T will be removed from the stack. So T is removed. Push this production or push the RHS of the production in reverse order. That means first we will push T dash, and on top of that we will get F. T dash and F is pushed to stack. Again, this while condition will be checked. X is not equal to dollar. So this if X equal to A will be checked. X is F, A is ID, so this is false. X is a terminal. X is not a terminal, so this will not be executed. If M x comma A is an error entry, here X is F, A is ID. FID represents this cell, it is not empty. So this will execute, output the production. So F gives ID will be printed as output. So F gives ID is printed as output. Pop the stack, F will be removed from the stack. F is removed. Push the production into the stack. Here only one terminal is there. So ID is pushed to stack. So now top of the stack contain ID. Again we are checking whether X not equal to dollar. X is ID, it is not equal to dollar. Here we are checking X equal to A. X is ID, A is ID. So this condition is true. So pop the stack and let A be the next symbol of W. So you have to do two things. Pop the stack, ID must be removed from the stack, and let A be the next symbol of W. We have to move this pointer towards right. You have to move this pointer towards right. You have to pop ID and also you have to move this pointer towards the right. So that symbol is popped out and the pointer A moves towards the right. Since it is else if, remaining things will not execute. Again, we will check whether x not equal to dollar, x not equal to dollar, x equal to a, x is t dash, a is plus, so this is also false. X is a terminal, that condition is also false because x is t dash. M x comma a, it means x is t dash, x comma a means t dash comma plus. In t dash row plus column we have a production t dash gives epsilon. So output the production. So in output we have to print t dash gives epsilon. So t dash gives epsilon is printed. Pop the stack. So this t dash will be removed from the stack. So t dash is removed. Then push the right hand side of the production onto stack. Here we have a production t dash gives epsilon. Since epsilon is a null string or empty string, we have nothing to push to stack. So the stack will remain as it is. So nothing is pushed to stack since it is epsilon. Again we will check the condition. X is not equal to dollar because x is e dash. X equal to a, it is also false because a is plus, x is e dash. X is a terminal, it is also false. Then we have to check whether e dash comma plus entry is empty or not. E dash comma plus entry is not empty, so this condition is also false. So anyway, this m x comma a means e dash comma plus have a production. E dash comma plus contain e dash gives plus t e dash, so that will be printed as output. So e dash gives plus t e dash is printed as output. Next step, pop the stack. So e dash will be removed from the stack. So now e dash is removed from the stack. Push yk minus 1 up to y1 onto stack with y1 on the top. So this plus t e dash must be pushed to stack in reverse order. So e dash is pushed, t is pushed and plus is pushed. Again we will test the while condition. X is still not equal to dollar because x is plus. X equal to a, this condition is true since x is plus, a is plus. So what do we have to do? We have to pop the stack, we have to remove this plus, and also we have to move this pointer a towards the right. So plus is popped and a moves towards the right. Since remaining things are under if else, it will not execute. It will again check the while condition. X is not equal to null. We are checking whether x equal to a, x is t, a equal to id. This condition is also false. We have to check whether x is a terminal, x is not a terminal, so this is also false. Then we have to check mx comma a, that means t comma id. T comma id contain a production, so this is also false. So anyway, this condition will be true, so output the production. So which one we will print as output? ta, t gives ft dash will be printed. So t gives ft dash is printed. Pop the stack, t will be removed from the stack. Then push the production in reverse order. T dash and f is pushed to stack. Again we will test the while condition. This while condition is true because x is f, which is not dollar. X equal to a is false, x is a terminal is false. The entry f comma id. F comma id contains an entry, so this one is also false. But this condition is true, so that production will be printed. So f gives id is printed. Then pop the stack, so f will be removed from the stack. Push the production to stack. So this id will be pushed to stack. Okay, next we are checking whether x not equal to dollar. Here x is id, which is not equal to dollar. Then this we are checking whether x is equal to a. So x is id, a is id, so id is id. So we have to pop id from the stack, and also the pointer a will move towards right. So a moved towards the right, and that id is popped from the stack. x is not a terminal, m of x comma a. Here x is t dash, a is dollar. So what happens in t dash dollar? We have an entry. So this condition is also false. But this condition is true. So output the production. So t dash comma dollar. T dash comma dollar means t dash gives epsilon will be printed as output. So t dash gives epsilon is printed as output. Pop the stack. T dash is removed from the stack. Push the production stack. Since it is epsilon, we are not doing anything. Again, we are checking the condition. X is still not equal to dollar because x is e dash. We are checking whether x equal to a. X is e dash, a is dollar. So this condition is false. We are checking whether x is a terminal. X is not a terminal. We are checking whether is it an error entry. But e dash comma dollar contain e dash gives epsilon. So it is not an error entry. So it will execute this statement. Output the production. So e dash gives epsilon will produce as output. So e dash gives epsilon will appear in the output. Pop the stack. E dash will be removed from the stack. Push the production to stack. Since it is epsilon, nothing will be inserted to stack. Again, this while condition will be checked. Now x is dollar. So this while condition will not be true. So these steps 4 to 13 will not be executed anymore. So the execution of algorithm is over. So now what you notice is, you have noticed the output. So this is the output which is generated from the parser. So this is the output which is generated from the parser. We already studied predictive parsing is a top-down parser. So it will start from start symbol. So first it will take t, e gives t dash. So t dash. Then that t will be replaced by ft dash. So this t is replaced by this ft dash. So ft dash e dash. Then this f is replaced by id. So id t dash e dash. Then this e dash will be replaced by epsilon. So I got id e dash. Then this e dash will be replaced by plus t e dash. So I got id plus t e dash. Then t is replaced by ft dash. So id plus ft dash e dash. Then f gives id. So this f is replaced by id. So I got id plus id t dash e dash. Then t dash is replaced with epsilon. So I got id plus id e dash. Then this e dash is replaced with epsilon. So I got id plus id. By making use of this sequence, we can generate this derivation. So that means we can generate the parse tree. So by following this production, we can draw a parse tree also. So that will be the output of predictive parser. So if you remember the input given, it is id plus id. So that is the input given to the parser. So what is the output? So output, here it is given as derivation, but that is similar to, or that is same as that parse tree. So id plus id is represented in a parse tree. If you draw an equivalent parse tree, you will get a parse tree. So I hope you understood the working of predictive parsing and how parsing table is constructed. That's all I want to convey in this video. Thank you.